This is video number 3 for sections 3.3 and 3.4, QVT problems, value problems. This is now the second major type of application we're seeing in this lesson. We did the modeling problems, now we're doing QVT problems. That stands for quantity times valuation equals total value. There's always some sort of amount, the quantity. There's a multiplying valuation of some kind that results in some sort of total value being determined. There are 3 different types of QVT problems. In this video, we're going to tackle just simple value problems. Now, before we do the real problem, let's just do some thinking about value. Here's a simple situation. Somebody's holding in their hand 7 quarters and 18 dimes. Okay, well, one question I could ask is, so how many coins are they holding? That's very, very easy. They've got 7 quarters, 18 dimes, 7 plus 18, 25. That's just a simple quantity question. How many? On the other hand, if I started asking, okay, but how much money do they have? What's the total value? Well, that's a little bit more complicated, right? Because you have to take those 7 quarters and you have to multiply by the valuation of a quarter, namely 25 cents, which is $1.75. And then for the dimes, you'd have to take those 18 dimes and you'd have to multiply it by the valuation of a dime, 10 cents, to get $1.80. And then if you wanted the total value of all that, you'd have to add up those 2 pieces for a total value of $3.55. The point is simply, when you want to talk about some kind of total value, you do how much you have times the valuation to give you that total value. Okay, so let's now try the actual word problem here. And I'm just going to worry about the setup of the system of equations. I think you can do the algebra yourself if you want the extra practice. Here's the situation. We've got a theater. It says they had a show. They sold 300 tickets one night. They look in their register the next morning. They have $1,670. Maybe somebody, though, forgot to write down how many tickets went to kids and how many tickets went to adults. They know that kid tickets were $3 each and adult tickets were $6.50 each, but they don't know how many of each they sold, and they'd like to figure that out. Okay? Well, if we're going to use algebra to answer this kind of a question, we have to begin by defining variables for everything we don't know. You have to go back to the question and really look for, what are you being asked? Here it is, right here at the end. How many, it's a how many question, it's a quantity question. How many of each kind of ticket were sold? In other words, one of the variables needs to represent the number of child tickets, and the other one is the number of adult tickets. You can use X and Y if you want. I like to use letters that help me remember what they stand for. So I think I would have C stand for the number of child tickets, and then A can stand for the number of adult tickets. It's important to write that down, both for yourself and for somebody who's looking at your work. Okay, I find it very, very helpful in all of these QVT problems to organize the information in what you might call a QVT table. They always have 2 rows and 3 columns. The columns are for quantity, valuation, and total value. The rows are for the 2 items you're talking about in that particular problem. In this case, we've got child tickets and we've got adult tickets. And then we need to start filling in these boxes. Remember, Q stands for quantity, how many. So this box, I should fill in how many child tickets there were. The thing is, I don't know how many there were, but I gave it a name, didn't I? The number of child tickets we called C. And then in the box below, I should fill in how many adult tickets there were. Again, I don't know, but we gave it a name, namely A. The V column, that's the valuation of a child's ticket in this box or an adult ticket in this box. Well, that they gave me in the problem. I know how much a child ticket is worth. A child ticket is worth $3. So I write 3. An adult ticket is worth $6.50. I can write 6.5 or 6.50. Now, here comes the best part. You don't ever have to think about what to put in the final box, the total value box, because we know this relationship exists every time. It's always Q times V equals T. So all you have to do is multiply the first two boxes and write that in the third box. C times 3, that would be 3C. A times 6.5, that would be 6.5A. Now that my boxes are filled in, I can start writing equations. I'm going to have to write two equations because there are two unknowns. In other words, I'm going to have to write a system of equations. How do you come up with the equations? Well, go to your box. Any column that has variables in it typically results in an equation. In other words, I'm expecting to get some kind of quantity equation, and I'm expecting to get some kind of total value equation. What I need to do is go back up to my problem and see. Let's start with the quantity. Is there any other quantity information? Quantity just means how many tickets. Well, it's right at the start. I know that in all, the theater sold 300 tickets. In all means that's a total, right? And total makes me think addition. C stands for how many child tickets there were. A stands for how many adult tickets there were. If you add up those two numbers, you have to get 300. Well, there's my first equation. That's a pretty simple one. 300 tickets in all, add up the two pieces, you got to get 300. Okay, then I'm going to write a second equation. The second equation is the one that's going to have to do with total value. What does this 3C represent? It represents the total money that came in from the child tickets. They sold C tickets. They cost $3 a piece. So 3 times C is all the money that came in for the kids. 6.5A is all the money that came in for the adults. But didn't they give me a total? Yes. The total of all that money was 1,670. Well, again, when I hear total, I think addition. So if I take the money that came in from the kids plus the money that came in from the adults, I have to get that total, 1,670. We have just written now a system of equations, and we could go ahead and solve this system in order to figure out what we want to know, namely the A and the C. In terms of method, you would want to use either substitution or elimination. It's kind of a toss-up here as to which one would be easier. I could see where the substitution method wouldn't be too bad. You could solve this top equation for either C or A pretty easily. On the other hand, I could see elimination not being too bad. You could multiply through the top equation by -3 to make these guys go away. You might want to try that on your own. If you do try it on your own, you should end up with A equals 220 and C is 80. In other words, 220 adult tickets and 80 child tickets. When you are working value problems on the homework, have this example out in front of you and try to follow similar steps.